Have you ever seen this keyword in SystemVerilog classes and felt confused? Don't worry, we will make it crystal clear. First, what is this? In simple word, this is the handle of the current object. It refers to the current class instance. Very important rule. This can be used only inside non-static class method. Now let's see why we need it. Let's look at this example. Here I will write class transaction and then I have 32-bit data and then integer ID. Now the constructor part, function new open bracket bit 32 data comma int ID close bracket semicolon. Inside it we write data equals data and ID equals ID, then end function end class. Now what is happening here? When I say data equals data, the compiler get confused because both are named data. One is the class property, the other is the function argument. So what happens? The argument assigned to itself, same for ID. So when we display, it will show value of data equals 0, value of ID equals 0 because class properties were never updated. This is called name ambiguity. Now how do we fix it? Using this keyword. Now I change the constructor to this dot data equals data, this dot ID equals ID. Here, this dot data means the class member and only data means the argument. Now we are clearly telling the compiler that assign argument data to the object data. Now the output becomes value of data equal 5, value of ID equal 1. So remember these four golden rules. This refers to current object, used to resolve name ambiguity, cannot be used inside static method, can be used inside non-static method even if written as a function static. If you understand this, SystemVerilog classes become much easier. Let's understand inheritance in SystemVerilog in the simplest way possible. Inheritance means one class can reuse the properties and method of another class. In SystemVerilog, we use the keyword extends. Now let's see the coding part. First I create a base class which is class transaction. Inside this I declare two properties, 32-bit data and integer ID. Now I write the method function word display. Inside it I am displaying base transaction. Then I close the function and finally end class. So this is my parent class transaction. Now let's create a child class. Class write transaction, extend transaction. Notice here I use the keyword extends. This means write transaction inherits everything from transaction. Now inside the child class I add bit write enable. Then I override the display method. Function word display. Inside it I am displaying write transaction, then end function end class. Now here's the important concept. The child class automatically gets data, ID, display method. This is called code reuse. Now another important concept. If both parent and child have method with same name, the child method overrides the parent method. But for proper runtime behavior, the parent method should be declared as virtual function. That enables polymorphism. Also remember, SystemVerilog support only single inheritance. One class can extend only one parent class. Why is inheritance important? It reduces code duplication, makes test bench scalable, core concept of UVM. It enables polymorphism. Now the next topic is super keyword in SystemVerilog. How it calls the parent constructor, how it calls parent method, and why this is a favorite interview question. Calling parent constructor. Let's say we have a parent class. It has a variable called data and the constructor takes one argument d and assign it. Notice the constructor requires an argument. Now we create a child class that extends parent. It has its own variable extra. Now look carefully at this line, super.newd. This line is called the parent constructor. In SystemVerilog, if the parent constructor has arguments, it is not called automatically. If you forgot super.new, the parent variable data will not be initialized properly. Interview question, is super.new mandatory? So the answer is yes if parent constructor has argument and no if parent constructor has no arguments. Calling parent method. Now suppose parent has a method called display. Now child overrides the display method. But look at this line super.display. This means first run parent logic, then run child logic. This is extremely important in UVM. In UVM, you always see this line super.build phase. If you skip this, base class functionality will not execute and your component will not get properly constructed. And debugging that is painful. Important difference. This refers to current class object. Super refers to immediate parent class. It does not jump to grandparent, only one level up. So remember, super.new calls parent constructor, super.method calls parent method. It is mandatory when parent constructor has arguments critical in UVM phases. And always remember, inheritance works only when you respect the parent. This is not just syntax, this is object-oriented thinking. Imagine this, you call a function using a base class handle. You are completely sure which method will execute, and then boom, a different function runs. Why? Just one keyword. Yes, that keyword is virtual, and if you ignore it, you might introduce silent bug in your verification environment. Imagine this, you create a child class object but assigned to a parent class handle. Now you call ptr.display. Question is, will it call the parent display or the child display? If the method is not declared as virtual in the base class, the parent class method execute, even though the object is of child type. Why? Because method binding happens at compile time. This is called static binding, and this can break polymorphism. With virtual, now add just one word, virtual function void display. Boom! Now when you call ptr.display, it executes the child class method because now binding happens at runtime. This is called dynamic binding. And this is the foundation of polymorphism in SystemVerilog. Important interview points. Important things you must remember. Virtual methods must be declared in the base class. Child class does not need to write virtual again. Function signature must be exactly same. Same name, same number of arguments, same type. Otherwise it will show compilation error. Real verification context. In UVM, copy, clone, do print all rely on virtual method. If you forget virtual, your scoreboard, monitor, transactions may silently behave incorrectly, and debugging that is painful. So next time when you design a base transaction class, ask yourself, do I want polymorphism? If yes, never forget the virtual keyword because in verification, small keyword create big difference. If this helped you understand virtual better than before, subscribe to Logic Verify where we build understanding, not just syntax.